we know how to add scalars. If you have the number 1 to which you want to add number 2, you will end up with another scalar, in this case number 3. So if you add two scalars together, you end up with another scalar. We can use the same technique and the same operator to add two vectors. So if I have vector A and I want to add another vector to it, let's say vector B, I will end up with a different vector. Let's call it vector C. The same way as you can move terms around if you use the operator addition with scalars, you have the same property, which is called the commutative law, with vectors. Therefore, A plus B is the same as B plus A. You can move terms around and the answer will be the same. So graphically, how does that work? If you have a vector A and you have a vector B and you would like to add A with B, all you have to do is graph A and you're going to graph B such that your vector B will start where vector A ends. Remember, the nice thing about vectors is that you can move them around as long as you don't change neither their magnitude nor their direction. It's the same vector. So you can take this vector and move it in such a way that vector B starts where A ends, and the vector sum, which is C, will be the vector that starts where A starts and ends where B ends. This would be my vector C, which is the resultant vector of A and B. Let's verify that this commutativity rule applies graphically. If you start with vector B and you want to add A to it, you start by plotting B and you're going to draw A such that A starts where B ends. And then vector C will be starting from where B started and ends where A ends. And obviously this vector C is the same as this vector C. We could see it right away by completing the parallelogram, where this vector B is the same as this vector B and this vector A is the same as this vector A. So you could go from this point to this point using vector C, or using vector A and then vector B, or by using vector B to which you add vector A. You can do it with two vectors, you can do it with three vectors. So if you want to add A plus B plus D, let's call this vector sum E. So you're going to start with A, you're going to add B to it, and let's say if D happens to be a vector pointing down, vector D will be drawn from the end of B, the same way as B was drawn from the end of A, and vector E will be the vector starting from the point where A started and would end where D ended. This would be my vector E. Now, if you add two vectors such that one is the opposite of the other. Remember, if you had a vector A, this would be minus A. So I would like to add those two vectors. I will use the same technique. I start with vector A, and I'm going to draw the vector minus A starting from the end of vector A. So the first vector was A, the second vector was minus A, and in this particular case I end up at the same position as the one I started with. Therefore, this will give me a vector with 0 length, which we call 0 vector. So we have to be careful. This is a scalar, 0. This is a vector, 0. So a vector 0 is, or 0 vector, is a vector of 0 length, which means that it's a 0-dimensional point. You can end up to the 0 vector by adding 2 vectors, 3 vectors, 4 vectors, 5 vectors, as many vectors as you want. A plus B plus C plus D plus E, in this case, will give me the 0 vector. So we have to be careful not to forget to put that little arrow on the top of your 0, because if this is the sum of vectors, the left hand side has to be a vector. If this is an equal sign, the right hand side has to be a vector also. Therefore, this wouldn't be correct, but this is. Okay, so adding vectors is pretty simple.